Have you ever imagined a world without bridges connecting landmasses? To cross wide rivers without bridges, one would have to use boats, take long detours, or even swim. This is undoubtedly less efficient compared to crossing via a bridge. Thus, bridges are not merely structures built from concrete and steel, they are also symbols of progress and unity among communities. Behind the sturdy and majestic appearance of bridges lies a complex construction process filled with meticulous calculations. A slight error in calculation could compromise the strength of the bridge, shortening its lifespan. There are 5 crucial steps in building a bridge: planning, laying the foundation, placing the pillars and support structures, completing the superstructure, and conducting safety inspections. As each bridge construction unfolds, the greatest challenge lies in building a strong foundation. This requires careful planning and consideration from engineers. After designing the bridge and meticulous planning, the first step for the contractors is to drill into the foundation. Equipment and materials needed for this project range from drilling rigs, cranes, reinforcing steel cages, concrete to tremie. Handling equipment such as loaders and skip pans is also required. The next stage involves excavation, which includes drilling and stability testing. Once the excavation is complete, all leftover material is removed and the holes are cleaned. If the holes are ready, the on-site crew will proceed with installing fabricated steel reinforcement cages. Finally, concrete is poured through a tremie, a large tube or pipe. The tremie is inserted through a mesh or steel cage, gradually lifted as the concrete is dispensed. Subsequently, the crew will build the superstructure atop the driven piles and pre-built caps. The substructure generally includes abutments, wing walls, docks, and decks. Next, the crew will construct the superstructure consisting of beams or girders, bearings, and the deck. The bridge design determines other crucial elements such as frames, arches, suspensions, cables, and barriers. The type of board pile foundation depends on several factors, such as the type of crust forming the water body base, currents and underwater pressures at different locations and depths, and the surrounding terrain, such as below and around the abutments. There are several board pile foundation methods ranging from straight shaft and bearing piles, straight shaft with sidewall shear piles, straight shaft with sidewall and end bearing piles, to belt or under-reamed piles. After completing the foundation drilling, the next step is bridge construction. It is essential to note that there are 2 types of bridge construction over water: shallow water bridge construction and deep water bridge construction. Shallow water bridges are often supported by pile foundations. Pile foundations are created by driving large piles, typically made of concrete or steel, into the submerged ground using a pile driver. Achieving the driving target often requires a floating platform on the surface. When the pile touches hard soil layers, it will bend inward or outward at an angle, providing lateral support. The final step of this process is to install piles to distribute the weight and bridge loads beneath the surface. To facilitate the construction process of shallow water bridges, coffer dams are needed, especially during bridge foundation installation. Coffer dams are watertight enclosures first developed by the Romans. At that time, coffer dams still used wooden boards. Coffer dams work by pumping out the water inside, providing stable ground for workers. Nowadays, most coffer dams are made of sheet piles or steel plates. To drive these components into the ground, a large hammer is required. Once the bridge structure is completed, the coffer dams can be removed. However, some bridge construction use cofferdams made of soil dumped into the surrounding water. Unfortunately, collapses are more likely to occur due to the permeable nature of cofferdams made of soil piles. Essentially, cofferdams act as barriers or dams that hold water on a large scale. The difference is that there is no need to build dams or dikes covering the entire river span for bridge foundations. There are 4 types of cofferdams: boxed and braced cofferdams, single and double-walled cofferdams, cellular cofferdams, and modular cofferdams. The boxed and braced cofferdams method requires many steel plate sheets to create a larger cage. These sheets must have supports at the bottom to prevent collapse. Soil, sand, and rocks can act as supports for these sheets. Meanwhile, single and double-walled cofferdams have thicker and larger designs compared to boxed and braced. Double-walled cofferdams are preferred in large-scale projects because they are considered stronger and watertight. Then we have cellular cofferdams, where several plate sheets are installed side by side to form a series of cells, interconnected to form a watertight cover. This type of cofferdams may have single or double walls with braces for better stability. Cellular cofferdams usually provide access to large machines such as cranes and drilling equipment. Meanwhile, modular cofferdams are versatile types of cofferdams. Instead of installing sheets or piles directly onto the ground, a frame is used to hold the entire cofferdams. These types of cofferdams can have waterproof bases, such as vinyl or other fabrics capable of preventing water seepage. On the other hand, bridge construction in deep water is more complicated than bridges built in shallow water. There are different strategies for building bridges in deep water, one of which is using casins. At first glance, casins and cofferdams look the same, but casins are hollow structures, usually square or cylindrical in shape, necessary for bridges requiring piers like suspension bridges. Unlike cofferdams built directly at the construction site, casins are often constructed elsewhere. One type of casins is box casins, which have an open top and closed bottom. Box casins are commonly used for bridges over the ocean. Before box casins are installed, contractors will first install foundations of rocks and soil. Concrete can then be poured into the structure to seal it and provide stability. Apart from box casins, pneumatic casins can be used in some cases. These can control the flow of soil and water into the structure. The inside of the structure is designed to be airtight and pressurized, allowing workers to enter and excavate soil. However, bridge construction in deep water often also use pile foundations. Once the bridge foundation is perfectly installed, the final step is to install the bridge on top of the previously installed foundations and piles. Like the Casin's technique, the bridge's upper part can be built off-site or on-site. The method involves transporting the prefabricated bridge foundation parts to the site. The process includes floating and lowering driven piles or ducts pre-assembled into the water, then installing them using previously existing foundations. Especially the on-site installation method does not always require casins or cofferdams. Crews can work from floating barges near or at the project site. Building bridges over water is not as easy as we might imagine. There are various challenges that often arise during the project. Therefore, contractors must also be familiar with the surrounding environment where the bridge will be built. This includes specific location, lake bed composition, and seabed bottom. Especially the seabed foundation, which has a much greater depth than the river or lake bottom. Thus, engineers must carefully consider its salinity.